Well, thank you for tuning in. Welcome to another wonderful math lesson. Today I'd like to introduce you to something I love talking about is slope. So our goal today is for you to understand what slope means, the definition, and then to be able to graph a line if I give you the slope and I want you to be able to graph it for me. So let's take a look at what we need to know. I need you to remember how to graph coordinate points, first of all. And I want you to keep in mind, remember how with coordinate points, x is first and then y. And something just a way to remember that, I'd like you to think of graphing coordinate points as being like an elevator. You have to step on the horizontal. All right, let's see. Like if we were going to graph this 2, 4 here, on the teeny tiny little graph over here, I would start at the center. So you would start in front of the elevator. Before you can do anything else, you've got to step onto the elevator. So you go from here to here. It is a step, okay? And we take 2. Then you get in the elevator, and then you push your buttons to decide which way you want to go, up or down, and how far. And if you want to go up, whoops, there we go. Okay, then we would get to our location. All right, so it's like an elevator where if you're standing in front of the elevator, you have to step forward or horizontally in order to go up and get to that y value. And it's a location. Okay, coordinate points are just one location. So that's different than slope. So some things about slope. Slope is just the measure of its steepness. Okay, if you think about it, it's kind of like mountains. Some are really steep and others are like hills. And here's some examples on the board for you to see some different types of slope and why slope is important. For instance, flying a plane. If a pilot were to try to land and he's coming in at too steep of a slope, well, you're going to go boom right into the runway and not slide along it and stop. Trucks, you can see there, they need to know what the grade is so they know whether to shift, downshift, or how much brakes to use. And for those of you who live in the Pittsburgh area, I know you've got a lot of really steep hills and stuff, and they've got a lot of places for runaway trucks to head so that they don't come crashing down into town and kill people. So, you know, the steepness of things is really important. When you're snowboarding or skiing, if you're not very experienced, you don't want to take the really steep hill like the one that's showing there and run into that pine tree. You want to take a bunny trail, which is a little more level, not as steep. It doesn't get you going as fast. Slope is very important. So I want you to think of slope instead of this is as the opposite of coordinate points. Okay, I want you to think of slope like stairs. And I want to watch this little video. See down here, I've got this little video here. This is someone taking the stairs. Notice the person is standing in front of the stairs. Just like you're standing in front with the coordinate points, you were standing already in front of the elevator. Notice how he's standing already in front of the stairs. Let's take a look at this video together. Really in slow motion, and watch how it's like stairs. Okay. Notice how he stepped up before he stepped forward. Okay, he's going up before he goes forward. Up, and then forward. He brings that foot all the way up. Let's see that again. Notice, all right, up and forward. Up and forward. Okay, that's how stairs work. Well, that's how we're going to do this in on the graph with slope. Let me illustrate that as soon as I get my picture back for you. There we go. Okay, so watch how this, I'm going to just show you how this line, and I'll tell you, this line has a slope of 1, and we're going to go up 1 and over 1. Watch my arrows as I put them in there. Up 1 and over 1, over and over and over again. slope is not a location on the line. Slope is how we get from one point to another on the line. So you see how that goes up. And we just keep going, kind of like climbing stairs. That's what slope is. Slope is like stairs, S and S, and then coordinate points are more like an elevator, and I'm not sure how you get that. Points, elevator. Okay, PE. Anyway, some more slope facts. There are different kinds of slope, 4 different ones. If it's going in this direction, slope is positive. And we're going to learn more about that in a few minutes. If it's going the other way, we consider that to be a negative slope. Okay. If it's flat, like a horizontal line, it is actually a slope of 0. And then straight up and down, we just call that undefined or no slope. That's really crazy, huh? You want to do a slide down that? It's like coming down a pole, you know. There's no help. Oh, anyway. So another fun fact about slopes is you're going to see slope represented by the letter M. And students ask this all the time. Why? Why is it M? Well, nobody really knows for sure. It's that simple. You can Google it. Nobody's positive. I used to think it was because of a Greek letter or something, but I was apparently wrong because I Googled it. But what I like to do is think of M for slope and think of motion. All right? So if you associate that letter M with slope is motion, it'll help you remember which one is going to be a fraction answer and which one's going to be coordinate points. Okay, so you're going to see that in a minute. Slope is usually represented by a fraction or a whole number, which can be turned into a fraction, right? Whole number 5 is 5 over 1, so really it's by a fraction. That's why I say to everybody, think of the M as meaning the motion of slope. It's just my way of doing it, my way of thinking of it. So, how to find the slope of a line on an actual graph? As you can see, I've got some lines going on here. I got arrows actually going up 2 and over 3. Now that last one I just showed you, the slope was 1 or 1 over 1. This one's 2 over 3. We go up 2 over 3. Notice we're not going horizontal first, all right? This is the weird thing, all right? It's going to be the y direction on the top and the x direction on the bottom, which feels completely backwards. But think about stairs. You don't, if you're standing in front of that first step, like we just saw, you can't get your foot, oh, I'm down here too low where you can't see it. If you're standing in front of that first step with your feet, these are your feet, you can't go out with one of them because the step is in the way. It won't let you. You have to go up first, up, and then over, up, and then over. Okay. So that's really, looking on a graph, this is how you do it. You look for places where the line crosses nice, even, like a crisscross, okay? Like here and here. And then you count. How far up do I have to go to be even with that? And then how far to the right or left do I have to go to be back on my line? So it's up 2 over 1. We call that rise over run. When carpenters talk about stairs, they talk about the rise over the run. You got to have certain ratios of them or the stairs feel awkward. Have you ever tried to go up and down a set of stairs that were either like too big and like takes 2 steps for every, it's so awkward. Or have you ever tried to go down or up a set of stairs that are like too close and you feel like you're climbing a ladder? There's a certain way to do that. Mr. Horn can tell you more about it, but he's sick, so he won't do it today. Anyway, so how to find the slope of a line on a graph. The first thing you want to do is, like I said before, you want to identify where does my line crisscross on exactly the grid, right on the grid. And I've marked out the 3 places that this particular line does. So then once you do that, you can draw some stairs. I'm going to have you doing some drawing. Hopefully your printer is working so you can draw some things today. Go up, okay, go up, and then to the right, in this case. up and to the right. So how far up did I go? Well, let's see, 1, 2, 3. So I went up 3. I went to the right 2. Now I went up. Up is a positive direction. To the right is a positive direction. This is going to become very important in a few minutes. So my slope in this case, which is m, remember m is slope, is 3, which is the up or down direction, and the 2 in the denominator, 3 over 2. Okay? Simple? Can you do it? I know you can. If you're not sure, watch it again. Okay, your turn. Now I've already marked out all of the crisscross places on this one, so I made it easy for you. Okay, now this one's going in the other direction. Notice it's going this way instead of this way. So let's see if it works again. I'm going to start at the lower one. That's where I'd like to start. I want to change my pen color a little bit here. Let's make it a green. Okay. So I'm going to start, oops, if I can find my pen again, where'd it go? Oh, there it is. Way over there. Here we go. We're going to go up, and look at this one. This one goes up a ways. Whoops, green. Up, 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 all the way up to here to be even with that dot. I moved all the way up there. Okay. Now, I go to the left. Wow, this is different. Going to the left. Where is my pen? Oh, I went off the pad. That does help. You stay on the pad, Mrs. Horn. There we go. All the way over there. Oops. This is a really sad drawing, isn't it? It's a good thing I'm not having to draw for a living. All right, so we go up. Let's see how many. We went 1, 2, 3, 4. I went up 4. Okay, so that's 4. Now I went left. Left is a negative direction. Remember, the negative numbers are on the left side? So I went left by 4. Oh, no, by how many? 1, 2, 3. By negative 3. So, again, don't forget that slope is a movement. It's going to be a fraction. And we went up 4. That is what we put in the top. And we went to the left 3, negative 3. It can also be written like this, negative out front, because either one of those numbers can be negative. What would happen if I decided to start at a higher number? Did you notice that there is another place on this map in the higher section where this, another color here, where we have another spot where it crisscrosses? Look at there, right there. What if I had decided I wanted to start there and end up down here? Well, I can do that. I don't get to get the same answer. Watch this. I go down, all the way down to that far, right? Well, how far down is that? It's 1, 2, 3, 4. It is 4. But think of this. I'm going down. Negative numbers are down in the bottom of the Y. I'm in the negative direction. I'm going down. Okay, so it's negative 4. And then to the right, to get there, how far did I have to go? You guessed it. I had to go 3. So in this case, slope is negative 4, positive 3, which is also the same thing as putting that negative sign out front and doing negative 4/3. So it really doesn't matter where you start. Just keep track of where you're going, how you're getting there. That's the important thing. Okay, time for you to do one. Another one. This time you have to decide what the second crisscross is going to be that you're going to use. I see a couple of them there. I see 1, 2, 3, 4 more. And last one for you. I want to do one thing with this one. I just thought of this real quick before we run out of time. We're out of time. So, in summary, do you understand the definition of slope? I hope so. If you don't, go back and watch this again. Also, can you find the slope of a line when I give you a graph? If you can't, if you're not sure, go back and watch this again. so that you know for sure you can. Have a great